Alright, so in this video we're going to be looking at the extreme value theorem, as well as critical points. So what is the extreme value theorem telling us? The extreme value theorem is basically stating something that should be very obvious. So the extreme value theorem, all it's saying is that if you have some function f, a function f, and this function is continuous, on some interval a to b, right? Well, then that means that this function f will have some, at least one, right? At least one minimum value and at least one maximum value. Has at least one min and one max value on the interval, on this interval. Right, and that makes sense. If we're looking at, for example, this is the graph of our function, this function f. Well, we can see that there's more than one, but at least there's one maximum and minimum value. Right? There's actually two maximum values here and two minimum values here. So you can see over this interval, if we say that this is the interval a to b, this is a to b, then we can see that there is at least one max and one min value on this interval. So that's all it's saying. Students often ask, well, what about if we have a straight line, right? If we have a straight line, then where are the mins and the maxes? And the answer is that every point along this line is considered a maximum, and every point along this line is also considered a minimum. So that's what we what we say if we have a straight line. But for any other function, there are going to be some clearly defined maximum and minimum values. So, now, what are we talking about when we talk about local extrema and absolute extrema, right? So when we're talking about, if we say the word extrema, that's referring to either a max or a min. So either a maximum or a minimum value. So the word extrema is referring to a maximum or a minimum. So what about absolute versus relative, right? So we can have either an absolute, we can have absolute extrema, and so absolute extrema versus relative extrema. Now, these are synonymous with the words global. So an absolute extrema is the same thing as a global extrema, and a relative is the same thing as local. So these are synonymous. You may see your teachers or an exam be referring to these concepts with either of these names. These are absolutely synonymous. So, but what is an absolute or a global extreme? So an absolute or global extreme is if it's the absolute highest point, right? For example, if we have a graph that looks something like this, right? Well, we can say that this is a maximum, this is a maximum, this is a maximum, this is a minimum, this is a minimum, this is also a minimum. The absolute max, right, is referring to the very most, the highest point along on this function. There's no point higher than this. So that's the absolute max. This is the absolute min. There is no, or, let's do this. This kind of, oops. So we had something like this, right? This is the absolute max. This is the absolute min. These are all also maxes and mins, but they are not the absolute. It's not the absolute highest, but this point is a maximum relative to what is next to it. So this is a relative maximum. This is also a relative maximum. This is a relative minimum, and this is also a relative minimum. Whereas these are the absolute or global extrema, the absolute max and the absolute min. So that's all we're talking about here when we're talking about absolute versus relative extrema. So now if we were given a graph, we need to be able to identify the absolute max and absolute mins of the graph if we're given one. So if we're given, let's just create something now on the spot here. So if we're drawing this spot, just do something like that, and then this goes up and this goes down. Let's make this whole, something over there. All right. Let's do that. And so we can do this. So if we're looking at something like this, let's identify what our absolute and relative extrema are. So we can see that clearly this point over here, but we can see that this is a continuous function. We see it's continuous here, or rather along the interval. But we can see that here we have a hole and a point corresponding to this, and this point here is clearly the lowest point for our function. It doesn't go anywhere below this, so this is going to be our absolute minimum. So this is the absolute minimum. Now, as we move along, we can see that over here we end up with a max, and this is a min, but let's just continue for the sake of identifying our absolute extrema first. And so then as we continue over here, we can see that this is our absolute max. Our absolute max. So now moving back along the function to identify the relative maxes and mins, we can see that this is a relative maximum, this is a relative minimum, and this is a relative minimum. So all we do is if we look at a point like this, when we have these hills and valleys, it becomes a lot easier. Usually the valley here is going to be a relative minimum because we can see that this point over here is relatively low compared to what is next to it. If we look directly over, we can see compared to what's on the right and what's on the left, this point is low, so this is a relative minimum. This is also a relative minimum, and this is a relative maximum. Now you notice I haven't mentioned anything about these points here. So what is the deal with those? And the thing is that there's actually a great deal of controversy here in that mathematicians themselves can't necessarily agree whether we would identify this as a relative maximum or just nothing altogether. And the reason is we can see that sure, this point is high relative to what is on the right of it, but there is nothing on the left to compare it to. So we can argue that this is a relative maximum because, hey, this point is high relative to what is on the right. So this is a relative max. But some people argue that this isn't because there's nothing on the left to compare it to. Only if we compare it to right and left and we see that this is a maximum, can we say that this is a relative max. So there is some controversy there. So I would recommend that you confirm with your teacher what they are expecting on their exams. And if this is for the AP exam, I can say with relatively high certainty that they wouldn't ask you something like this, just because even mathematicians themselves haven't come to an exact agreement as to how we can, categorize points like this. So, but if you are in a class, I'd recommend you confirm with your teacher what their expectations are. All right, so now that we're able to identify absolute maxes and, or absolute and relative extrema, let's move on to the idea of critical points. So what is a critical point? Now, actually, in order to sort of segment this and have it more, kind of squared off here, let's end this video here where we just talked about absolute and relative extrema. Critical points are essentially points that have the possibility of being a min or a max, and there is a method, to being able to figure out if something may be a critical point. And I think it would be more appropriate to dedicate a video to that on its own. So that does bring us to the end of this video then, where we talked about absolute and relative extrema, right, maxes and mins. Hopefully you found it useful. If you did, please show your support by liking and subscribing, and leave in the comments any questions that you may have, and I'll see you in the next video.